Okay. So yesterday we started the magnetic fields, magnetostatics under the static conditions, where we are represented the Biot-Savart's law. The first law. What is this Biot-Savart's law means? The magnetic field intensity can be defined as it is proportional to the product of the current and the differential magnitude of the differential length dl and the sine of the angle between that particular point, observation point, to that particular filament is represented as the cross product, and also it is indirectly proportional to or inversely proportional to the square of the distance from the differential element. So what is that mathematically how we are represented? That is dH is directly proportional to IDL sin alpha by r square. So therefore, that will be finally what we are represented. IDL sin alpha by 4 pi r square. So this particular case will be represented in terms of a cross product. So therefore, DH is equivalent to IDL cross AR bar by 4 pi r square. Now, and also we are represented, one more thing we are represented. What is that? So the direction of the magnetic field intensity is in a circular circular closed loops. If the current is moving along the direction of the Z, so therefore assuming that is a right hand thumb rule, if the thumb is pointing the direction of the current, therefore right hand fingers encircling the direction of the DH, direction of the magnetic field intensity. So that is the direction of the magnetic field intensity is always in a closed path, closed loop. And the source of, by observing that Biot-Savart's law, the source of the magnetic fields are current. So therefore, previously for the electrostatics, where we are represented, the source of the electrostatics is electric fields are represented as a charges. So therefore, different types of charge distributions were represented as a line charge, or a surface charge, or a volume charge were represented. Since here, the source of the magnetic fields are represented as a current. So therefore, what we are represented? The continuous charge distributions, like continuous charge distributions. Here also we are represented as a continuous current distributions as line current as an ideal, surface current as a KDS, volume current as a JDV. So therefore, according to the Biot-Savart's law, therefore magnetic field intensity is represented due to the line charge, due to the line current, or due to the surface current, or due to the volume current will be represented as like this. Okay. Now, this is actually what we are represented in the yesterday's class. Now, today what we are going to represent is put the subheading as a magnetic field intensity of an infinite long current filament. Magnetic field intensity of an infinite long current filament. Magnetic field intensity of an infinite long filament current. I want to represent that H is equivalent to. Okay. For that, I should consider as like this. This is an infinite filament along the z-axis. Infinite filament, this black color line I should represent it. Is an infinite filament. Is an infinite filament along the z-axis, and therefore the source point I should represent it as a point 1. The source point I should consider as a point 1. Observation point I should represent it as a point 2. Okay. And what is this? Of course, this is the differential. Now you should understand. This is a differential element with a length of dl. Point 1 కూడా పక్కకు జరుపుతామండి ఒక్క నిమిషం. This is a length of dl, assuming this is point 2. Sorry, point 1. Okay. And the current is, now write down. Is okay now? What is this? Is AR bar. You should represent this also. What is this? AR bar R, or simply R bar. This angle I want to represent as an alpha. One second, Andy. minutes. Please wait for 2 minutes.
Okay, sir.
Okay, we will start our class on it. So what is the case is where the line is current filament is infinite long filament is that black color thing. You should understand this is the case. Infinite long current filament is that black color line. Okay. And what is that? That current is traveling along z direction. And I should consider a small portion differential length dl. So therefore point 1 is an source point and point 2 is a observation point. Okay. Point 2 is an observation point. Now note down this is the case. Consider, write down this is the one, note down. Consider an infinite long conductor carrying a current I along the z axis okay. Let a current element ideal on the conductor at a distance z prime. I want to write that at a distance z, but source and what is the case? General, for example, what is the case for your again understanding, remembering point of view? Generally, observation point what we are represented x comma y comma z is represented as an observation point. Source point what we are represented x prime y prime z prime is represented as a source point. That is the reason. Okay, so that is the reason I am represented at a distance of z prime. Okay, what is the meaning of this one is I can represent here it is z prime az bar. Sorry. Z prime from the origin is clear. Whatever the two statements we are represented, that we are represented as a graphically also. Let us consider third point. Let us consider an observation point. Consider a point P. This is point P. Consider an observation point, or let us consider a point P on the y-axis. On the y-axis at a distance of rho. At a distance of rho from the origin. So what is the meaning of this one is, I want to represent, this is z prime az bar, this is r is equivalent to rho a bar. This is actually r you are represented, r is equivalent to rho a rho bar. Okay. From the origin, you can close like this as shown in the figure. So everything we are represented, whatever you are represented as a statement point of view, we are represented that as a graphical point of view also. Okay, clear? Are you represented? Everything. Can we move to the next point? So whatever the representation of a statement point of view, consider an infinite long conductor carrying a current I along z axis. అందుకనే దాన్ని సపరేట్గా ఇంకో కలర్తో చూపించానండి మీకు అబ్జర్వేషన్ కోసం. As in that black color line is represented as a current carrying conductor where the current is represented as an I and it should be along z axis. That is the first case. And observation point is represented as a point 2, source point is represented as a point 1. So therefore the differential element dl, the current element dl is represented as a z prime az bar from the origin. So therefore what is this? This is the origin, and r is equivalent to rho a bar for, as an observation point is represented. Now I want to represent here the next point I want to represent. In cylindrical coordinates, you should represent like this. In cylindrical coordinates, I want to use the cylindrical coordinate system. In cylindrical coordinates, the position at the current element, the position at the current element is z prime az bar, and the position vector, I want to write like this. The position vector at a point P is rho comma 0 comma 0. Here also I want to write that the position vector at the current element, you should write like this. The position vector at the current element is, instead of z prime az bar, అది ఆల్రెడీ పైన రిప్రజెంట్ చేసేసారు కాబట్టి 0 comma 0 comma z prime, and the position vector at a point P is rho comma 0 comma 0. Therefore the distance vector is r is equivalent to, what is that? Observation point minus a source point, that is, what is that? Rho a rho bar, r bar is equivalent to rho a rho bar minus z prime az bar. Am I correct or not? What you are represented, rho comma 0 comma 0 minus 0 comma 0 comma z prime. Your source point, observation point minus source point is represented as an AR bar. Okay, so therefore R is equivalent to magnitude of R is equivalent to square root of rho square plus z prime square. So therefore AR bar is equivalent to, AR bar means R bar by R modulus of R. So therefore rho A rho bar minus z prime Az bar divided by square root of rho square plus z prime square. Okay, clear? ఇవన్నీ మీకు థర్డ్ యూనిట్లో తెలిసినవేనండి నేను చూపించినవన్నీ. ఓకే, now DH is equivalent to, what is DH? IDL cross AR bar by 4 pi R square. Okay, DL is equivalent to what we are represented? DL is equivalent to DZ. DL is equivalent to DZ. So therefore I want to write that, see, I dz Az bar, because I is in the direction of Az bar, so that is the reason I dz Az bar cross. Now I should represent it AR bar. What is that? Rho A rho bar minus z prime Az bar divided by 4 pi this R square by R it is there. So therefore what I should represent it? Rho square plus z prime square whole power 3 by 2. Is clear? Are you followed that point?
Yes,
now
sir.
see, is it okay? Now what is the case is, now I want to go for cross product. What is that? Az bar cross A rho bar. What is this value? Similarly, Az bar cross Az bar. Here it is, you should observe that Az bar cross A rho bar for first term. Second term is Az bar cross Az bar. Are you following my point? What is that Az bar cross A rho bar? Can you tell me?
A5 bars.
Yes, A5 bar. Cross product is represented as, అందుకని ఆ రోజు చెప్పానండి మీకు, if you want to take it as in a circular case, what is that? This is assuming as a row, this I should consider as a phi, and this I should consider as a z. What is that? Clockwise direction I want to move. Az bar cross A rho bar, it is A5 bar. A5 bar cross Az bar, it is A rho bar. A rho bar cross A5 bar, it is Az bar. Cross product ki you should use, this is the case. ఇక్కడ ఏం చేయండి? Az bar cross A rho bar, it is A5 bar. For example, sometimes I may get, this is the case. If remember, this is the one. A rho bar cross Az bar. For example, this is the, this will be there. A rho bar cross Az bar. I want to move into the anti-clockwise direction. Therefore, it is minus A5 bar. If that will comes into the case, you should remember that is the point. A rho bar cross Az bar means I want to move in the anti-clockwise direction. A rho bar cross Az bar, which is an A5, but I want to represent minus A5. It is because of the anti-clockwise direction. But here, what is the case? Az bar cross A rho bar, it is in the clockwise direction only. That is the reason I want to represent A5. Very good. Now coming to that Az bar cross Az bar.
Zeros.
0. Az bar cross Az bar is equivalent to 0. So therefore, now what is my DH? DH is equivalent to I dz, okay, of rho A5 bar, because Az bar cross A rho bar is A5 bar. Az bar cross Az bar is 0. Therefore, I should not represent this term, divided by 4 pi times of rho square plus z prime square whole power 3 by 2. Is it clear? Is okay?
Yes, sir.
Now I want to represent this as I should represent as h is equivalent to, okay, means I want to represent an integral form. So therefore h is equivalent to I want to take an outside is a constant. By 4 pi I want to take into the outside of the integration. A5 bar is also I want to taken from the outside of the integration. Integral of minus infinity to plus infinity. Why I am represented minus infinity to plus infinity? The conductor, the conductor what we are represented is an infinite conductor. There is no limit. So that is the reason it will be from minus infinity to plus infinity. నేను ఊరికనే రాయలేదండి, నాకేదో తోచింది కదా అని. Where what is the case is it is minus infinity to plus infinity. Why I am consider your heading will represent that is the case. Your heading will be represented as an infinite long current. It will be what we are represented as an infinite conductor will be along z axis. So therefore from minus infinity to plus infinity along z axis. If it is a finite, I want to represent where my line will be. So this is z1 sir, this is z2 sir, a point which is considered as a z1, a point which is considered as a z2. I should not consider like that. It is an infinite. That is the reason from minus infinity to plus infinity. Okay, what is the pending terms? Rho, okay, dz by rho square plus z prime square whole power 3 by 2. We are every element, every term should be used. Am I correct or not? I can represent it here. Dz I should represent it here. Rho in the it should be represented in the integration itself. A5 bar I should represent it here. The denominator case of 4 pi I should represent. Rho square plus z prime square is represented as a 3. This is it. It's clear?
Yes, sir.
Now I want to consider. Now I will modify the integration. That is the reason. Consider. You should represent like this. Consider z prime is equivalent to, I want to write that rho tan alpha. Consider z prime is equivalent. Alpha means the angle which is made from the observation point with respect to the current element. So I should consider as a z prime is equivalent to rho tan alpha. Therefore dz prime is equivalent to dz prime. Here also dz or dz prime, whatever it is. Dz prime is dz is equivalent to what is that? What is this dz? Rho tan alpha will be represented as secant square alpha. అంతేనా అండి?
Sir.
Rho secant square alpha d alpha. మీరు చెప్పాలి, నేను కాదు, because you are the experts in the differentiation and integration. Now the limits of alpha will be reduced as, generally what is that alpha? Alpha is equivalent to what we are represented, tan inverse of z prime by rho. Okay, what is that? Is an minus infinity to plus infinity what we are represented. So therefore the limits of alpha will be the limits of alpha, the limits will be represented as, the limits will be as minus pi by 2 to pi by 2. Is it okay now? The limits will be represented as minus pi by 2 to pi by 2. Therefore, H is equivalent to, what is that? I by 4 pi A5 bar is okay. I by 4 pi A5 bar integral of, now it is minus pi by 2 to plus pi by 2. Okay. What is that? What is this is represented as? Dz will be represented as, now it is rho. Dz will be rho secant square alpha. Therefore, I want to write that rho square secant square alpha d alpha. Are you following my point? Originally here it is rho is there. So and dz is represented as rho secant square alpha d alpha divided by, okay, rho square plus, what is z prime? Rho square tan alpha. So therefore z prime square, z is equivalent to rho tan alpha. So therefore rho square tan square alpha whole power 3 by 2. Okay, so therefore, can you simplify this one? I by 4 pi A5 bar integral of minus pi by 2 to pi by 2. What is this completely? Can you tell me? If I will take that in the denominator as a, what is that? Rho square whole power 3 by 2. If I should take into the common. So therefore, what is that? Rho cube. Therefore, rho will be coming into the case. Am I correct or not? This rho square, if I should take the common term, rho square as a common, what is that? If I should take that rho square, it is rho square whole power 3 by 2. Rho square whole power 3 by 2 means rho cube. Rho cube means rho 1 by rho. Okay, so that is the reason in the upper numerator it is represented as a secant square alpha, and 1 plus tan square alpha is 1 plus tan square alpha is secant square alpha. Secant square alpha whole power 3 by 2 means secant cube alpha. So therefore, what is that? 1 by secant alpha. So therefore, now it is the entire integration is with respect to alpha. Therefore, rho is a constant. I want to take an outside as I by 4 pi rho. I want to take an as a, this is the outside as the case. A5 bar integral minus pi by 2 to pi by 2. 1 by cos 1 by secant alpha is represented as cos alpha d alpha. Now tell me what is the case. Now tell me what is the complete solution as H is equivalent to. H is equivalent to.
2 pi A5 bar by rho.
So what is the case is I by 4 pi rho A5 bar. What is the value of this integration? Cos alpha is represented as cos alpha. Integral of cos alpha d alpha is
Sin
sin
alpha.
alpha. Sin pi by 2 minus of minus sin by 2. Therefore, it is overall it is 2. So therefore, what is that final solution? So therefore, H is equivalent to I by this 2 4. What is the case is 2 pi rho A5 bar. What is this? Of course, units also you should represent amperes per meter. Remember, if you write that electric field intensity, what are that units? Volts per meter. If I should represent the magnetic field, what are that units? Ampere per meters. Remember these two things, very important. Where my H is equivalent to I by 2 pi rho A phi bar. Now here I want to represent one thing. According to the Biot-Savart's law, what we are represented. Sir, it is a closed circular loop, sir, you are represented. Am I correct or not? You are defined as my magnetic field intensity should be always as a closed circular loops. Closed loops will be represented. That is what is the case. I will once again I will minimize. This is the one. Please wait. Please. Okay. See what you are represented. If the current carrying, that is your right hand rule represents, thumb indicates, this thumb indicates the direction of the current. So therefore, what is that? Your magnetic field is in the direction of your all fingers. Remaining fingers will represent the direction of, so what we are defined. So therefore it is in the, like this, it is in a closed form. Now what is the case? Sir, a current carrying, now what is that? An infinite current carrying along the z axis. The current is along the z axis. I is represented in the diagram also. What we are represented? I is in the direction of z. Now what finally what you are closed? Sir, my H is equivalent to something I by 2 pi rho. Rho is the dimension of your conductor. What is rho? Rho is the dimension of your conductor. It's a constant. If I should represent the conductor of a radius, rho is equivalent to. So that is, if I should consider, that is rho. And I is already defined. I is a source of your field. That is the reason I by 2 pi rho. And it is in A phi direction. What is the direction of A phi? Generally, if it is a cylinder, if you consider this as a cylinder, so what is that? Rho is the radius of the case. Z is represented as height of the cylinder. Phi is represented as a circumference of the cylinder. In the cylindrical coordinate system, what is rho phi z? Rho is represented as a radius of the cylinder. Okay, one second. Assuming this is a cylinder, what is that? The radius of the cylinder will be represented as a rho, height of the cylinder will be represented as a z, then circumference of the cylinder will be represented as a phi. అందుకని మీరు లిమిట్స్ ఎలా రాస్తారండి? సో లిమిట్స్ ఆర్ రిప్రజెంటెడ్ యాజ్ a 0 to rho. Rho, according to the definition, we are represented 0 to rho. Height is represented as minus z to plus z or 0 to z. But phi is 0 to 2 pi. What is that? 0 to 2 pi. This is the one. Circumference of the case is 0 to 2 pi. Now, what is your H? Sir, my magnetic field intensity H is equivalent to, if I should take a conductor, infinite conductor carrying a current I along the z axis, according to the thumb rule, what you are represented? You are represented according to the thumb rule. If the current is carrying along this direction, it should be represented as in the, your fingers will be represented as a encircles the, that means it is in a closed path will be represented. Now also that is the case. If you represent the magnitude of the magnetic field intensity will be represented as an I by 2 pi rho, where the direction of the magnetic field intensity will be represented as in the phi direction. Now what is that phi direction? This is the phi direction. It should be proved what we are represented as. That is, it should be in the phi direction. If you observe, this is the case. It should be in the phi direction. What you are defined, you are proved that I by 2 pi rho A phi bar. A phi bar means this is the case. My magnetic field intensity H is in the, as like this. Are you following my point? Are you understand what we are represented in the mathematical expression? Now one second. I will close that video because you may get that more data. Consumption of your more data will be there. So that is the reason. Are you understand what now? See what is the case. So if I should take into the consideration as a current conductor as like this, my loop will be represented, that is this is the case. H should be as like this. అందుకని మీరు ఇక్కడ ఏం చేస్తారంటే you should represent like this. Don't put this is the one. You should write like this. Now imagine this is the top view of your cylinder. You should represent like this. Now, by observing that above equation, close like this. By observing that above equation, I want to close like this. By observing that above equation. Above equation is this is the one. Write down like this. By observing the above equation, the magnitude of the magnetic field is not a function of phi and z. Am I correct or not? The magnitude of the magnetic field is not a function of phi and z because it is a function of rho only. The magnitude of the field is not a function of phi and z, and it varies inversely. It varies inversely as the distance from the filament okay. What you are represented, the magnitude of the, once again I will repeat the case, the magnitude of the field is not, నేను రాయటలేదు మీరు రాస్తారు కదా, the magnitude of the field is not a function of phi and z, and it varies inversely as the distance from the filament. Okay, the second point, the direction of the h, the direction of the h is along phi. The direction of the h is along phi. It is a tangential. Write down. It is a tangential to the concentric circles. It is a tangential to the concentric circles around the conductor, as shown in the figure. What is that figure? Is this is the one. This is the figure as shown in the figure. Once again, I will repeat that second point. The direction of h is along phi. The direction of h is along phi. Equation, by observing the above equation, observations rastunnamandi. By observing that above equation, what is that? The magnitude of the magnetic field intensity is not a function of phi and z, and it is varies inversely as the distance from the filament, or it is indirectly inversely proportional to the rho. You can write like that also, is not a purpose. It is inversely proportional to the direction of rho. You can write like that also. Okay, and the second point is the direction of the magnetic field intensity is along phi direction. Full stop. It is tangential to the concentric circles. It is tangential to the concentric circles around the conductor, as shown in the figure. Okay, ఇప్పుడు now you can now within brackets you can represent one more thing also, and it follows that right hand thumb rule. Therefore మీకు గుర్తొస్తుందండి, and it follows that within brackets you should write down, and it follows the right hand thumb rule. It follows that right hand thumb rule. You are represented that right hand thumb rule in the above. You are represented, that is the case. Okay, are you understand? This is the case. Clear? the magnetic field intensity, what we are represented, we are derived that one equation as a magnetic field intensity of an infinite long current filament. What is that? Sir, my H is equivalent to I by 2 pi rho A phi bar. Now, in the next class, what we are going to represent is the same concepts we are represented, same thing we are going to represent. Okay, instead of representing the infinite current, we want to go for the finite length of the current element. Okay, I want to consider a finite element. That finite element will be represented as a Z1 to Z2. So therefore, we want to go for the magnetic field intensity of a finite length of the current element along the Z axis we want to represent. Okay, so then after that we will go for the Ampere's circuit law, a very important law which is going to represent, that is represented as an Ampere's circuit law. So at this stage I want to close today's class. If you have any doubts, you can raise your doubts, no problem. So if you have any doubts are there, you can raise your doubts, please. We don't have any doubts in this particular today's class, therefore we will stop our presentation and we will see. If you are not practice చేస్తున్నారండి మళ్ళీ once again I will repeat, this is the case. Be practice every day. ఓకే, ఆల్రెడీ థర్డ్ యూనిట్ అయిపోయింది, ఫీల్డ్ థియరీలోకి వచ్చేసాము. ట్రాన్స్మిషన్ లైన్స్ ఆర్ క్వైట్ ఈజీ దాన్ ద ఫీల్డ్ థియరీ. ఫీల్డ్ థియరీ వన్స్ యు ఆర్ ప్రాక్టీస్డ్, దేర్ఫోర్ ఇట్ ఈస్ వెరీ ఈజీ వెన్ కంపేర్డ్ విత్ ద ట్రాన్స్మిషన్ లైన్. ట్రాన్స్మిషన్ లైన్స్ కన్నా ఈజీగా ఉంటుందండి ఫీల్డ్ థియరీ. But only thing is you should practice. That is the reason I request several times, practice every day 1 or 2 examples, 1 or 2 problems on that particular topic. మీరు పొటెన్షియల్ అని తీసుకున్నారనుకోండి, ఒక 4-5 ప్రాబ్లమ్స్ చేయండి. Okay, therefore how I will find out that from the potential, how I will find out the electric field intensities, like that you should start your preparations. Okay, I will stop at this stage. From this link I am leaving. So at 10:50 another class will be there. Okay, thank you.